Hi everyone, welcome back to BSc Chemistry Study Room. If you are new to this room, please subscribe for more videos. And if you have already subscribed to this room, please click the notification button for more video updates. In today's video, we are going to discuss Introduction to Matrices and solve some examples related to matrices. Matrix is a rectangular arrangement of numbers, letters, elements, or sign. Example, this is a sign, alphabet, beta, and it is arranged in a rectangular form. 1, 2, 3, 4 are numbers arranged in a rectangular form. A, B, C, and D are letters arranged in rectangular form, etc. So now let's see the presentation of matrices. Matrices are presented in capital letters, while the elements in small letters. The elements in the matrices are presented in small letters. Example, let A be a matrix of A, B, C, D, E, F. The matrix is presented in capital letter, while the elements of the matrices is in small letters. A, D, B, E, C, F are letters in small letters. So, there is what we call order of matrix. Order of matrix show us how many rows are in matrix and how many columns are in matrix. When we look to a matrix, here are the rows: R1, R2, R3. This shows us that there are 3 rows inside matrix A: row 1, row 2, and row 3. So let's see how many columns do we have inside this matrix. This place represents the column C1, C2. Therefore, this matrix has 2 columns and 3 rows. So we can represent the order of this matrix, or write the order of this matrix as 3 by 2. We first write the rows. These 3 represent the rows and these 2 represent the columns. So this is the order of this matrix, 3 by 2. So we have different orders of matrix. We have 2 by 2 matrix. For example, A, B, C, D. We have row 1, row 2, column 1, column 2. This matrix can be the order of this matrix can be written as 2 by 2 matrix, since it has 2 rows and 2 columns. So let's go into the types of matrices. First, we have zero matrix. Zero matrix is a matrix whose elements are 0, i.e., let A be the matrix. The elements are 0. When all elements of a matrix is 0, or the letters or numbers or signs inside the matrix is 0, so that matrix is called zero matrix. And the order of this matrix will be row 1, row 2, column 1, column 2, column 3. Therefore, we have 2 by 3 matrix. These 2 represent the rows, while 3 represent the columns. We have identity matrix. Identity matrix, any matrix by which the diagonal terms are 1 is what we refer to identity matrix. Let Q be the matrix Therefore, the diagonal term, when we say diagonal term, we mean the lines crossing here. 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is the diagonal term. The diagonal terms are 1, and the order of this matrix is row 1, row 2, row 3, column 1, column 2, column 3. You can write the order of this matrix as 3 by 3 matrix. Diagonal matrix. Any matrix whose diagonal terms are numbers, i.e., let A be the matrix 1, 0, 0, 0, 2, 0, 0, 0, 3. This is a matrix whose diagonal terms are numbers. They are not identical numbers. They are numbers of different types. So this is what we call diagonal matrix, and we can represent the order of this matrix as row 1, row 2, row 3, column 1, column 2, column 3. We can call the order or write the order as 3 by 3 matrix. We have row matrix. It's a matrix having only one row. Any matrix that have only one row is called row matrix, i.e., let B be the matrix 1, 2, 3. It has only one row. This is the row. Only one row and 3 columns. 1, 2, 3. We can represent this matrix as 1 by 3 matrix. The 1 represents the row and the 3 columns represent this 3. Then we have column matrix. Matrix having only one column is called column matrix, i.e., let P be the matrix 2, 3, 4. It has only one column. This is the column. One column, but 3 rows. R1, R2, and R3. This is a matrix in order of 3 by 1. 3 represents the rows, while this one represents the column. We have square matrix. A square matrix is a matrix of order n by n, i.e., this means the number of row is equal to the number of column. This is what we refer as square matrix, i.e., let Z be the matrix B, C, D, A, E, F, G, H, I. We have 3 rows, row 1, row 2, row 3, and 3 columns, column 1, column 2, and column 3, in order of 3 by 3. This is what we call a square matrix, a matrix of order n by n. So let's discuss the algebraic of matrices. In matrix, and operations of addition, subtraction, multiplication, and scalar multiplication are taken place when necessary, but no division in matrix operation. There is no division in matrix operation. Let's discuss on the first one, addition and subtraction of matrices. This operation is done if and only if matrix A is equal to matrix B. It's only when matrix A is equal to matrix B, then we can add or subtract the matrices. For instance, the element inside matrix A must be equal to the element inside matrix B. So let A be these elements: A11, A12, A21, and A22. This A11, this 11, A11. The first one represents the row where this A is located, while the second one represents the column where this A is located. When we said A12, the first one represents the row where this A is located. These two represent that this A is located in the second column. So likewise in the B matrix. When solving this matrix, let's find A plus B and B minus A. So, solution: A plus B will be equal to matrix of A, A11, A12, A21, A22, plus matrix of B, B11, B12, B21, B22. So we are going to add or subtract. Now we are going to add each component by component. A11 plus B11. Now the matrix A plus B will be equal to A11, which it is component B11. A11 plus B11. B11. Then you shift and add A12 plus B12. A12 plus B12. You close the matrix. Then A21 plus B21. A21 plus B21. Then you make a space and add A22, A22 plus B22. This is how we add A plus B, matrix A plus B. When subtracting, let's find A minus B. A matrix of A minus B will be A11 minus B11. A11 minus B11. Then you shift and make the subtraction of A12 minus B12. Close the matrix. Then A21 minus B21. A21 minus B21. You make a space and make the operation of A22 minus B22. A22 minus B22. So this is how we make the operation of addition and subtraction of a matrix. I use letters in these matrices. So now let's see the numerical value of this subtraction or addition of a matrix. Let's solve this one. Let A be this matrix of 3 by 3, and B to be equal to matrix of 3 by 3 again. So let's find A plus B. A plus B will be equal to, first keep the matrix of A. Solution: 2 2, 2, 4, 1, 1. Then plus, keep the matrix of B. Matrix of B, 2, 0, 5, 4, 1, 2, 4, 1, 2, 3, 6, 2, 3, 6, 2. Close it. Then you make the operation now. A plus B will be each component by each component. Will be matrix of 2 plus 2, 4. 1 plus 0, 1. 0 plus 5, 5. Closed. 3 plus 4, 7. 2 plus 1, 3. 2 plus 2, 4. 4 plus 3, 7. 1 plus 6, 7. And 1 plus 2, 3. So this is the matrix of A plus B. I hope you will try this one, the subtraction one, A minus B. Subtract A inside B. So let's see scalar multiplication of matrices. Suppose lambda is a scalar, and let A be the matrix of these letters. Then lambda A will be equal to lambda with matrix of A. Then now, by distributing the scalar, A matrix of A will be equal to, we distribute this scalar, the lambda, we distribute it to the matrix. Lambda times A11, lambda A11. Lambda times A12, lambda A12. Lambda times A21, lambda A21. Lambda times A22, lambda A22. So this is how we distribute scalar multiplication of a matrix. Example, let A be this matrix. Then find 3A and 2A. Solution. To find 3A, 3A will be equal to 3. Then we write the matrix of A. Minus 1, 3, 2, 4, 5, and 6. Then now we distribute 3 to the matrix. 3A will be equal to 3 times minus 1. We have minus 3. 3 times 3 is 9. 3 times 2, 6. 3 times 4, 12. 3 times 5, 15. Then 3 times 6, 18. 12, 13. 18. So this is how we distribute or make the operation of scalar multiplication of a matrix. Let's find 2A. 2A. The matrix of 2A will be equal to, keep the 2, then open the matrix of A. Put the value of A. Minus 1, 3, 2, 4, 5, and 6. Then now distribute 2 to the matrix. 2A will be 2 times minus 1, minus 2. 2 times 4, 8. 2 times 3, 6. 2 times 5, 10. 2 times 2, 4. 2 times 6, 12. So this is how we make the operation of scalar multiplication of a matrix, by distributing the scalar to the matrix. Let's see multiplication of matrices. Two matrices A and B can be multiplied if and only if the numbers of column of A is equal to numbers of row of B. multiplication of matrix can be done when the numbers of column of A are equal to number of column of are equal to the numbers of row of B. Let this be a matrix A. The columns, one column C1, C2 are equal to the numbers of row of B. We have two columns here and two rows in matrix B. So then we can multiply matrix A and B. Let's find A, B. Solution. To find AB, first keep the matrices together. A11, A12, A21, A22. Bring the matrix of B, B11, B12. So, in multiplication of matrix, what we consider is, first, when you take one row of the first matrix, you will multiply it with all the matrices in B. Then you come again, carry the row of the first matrix and still multiply it with the matrix of B. Therefore, AB will be equal to A11 times B11. Then we have A11, B11. Then you shift and write a plus. Then A12, B12. Let me change column. A12, B12. Then you write it here. A12, B12. Then you close the matrix. When you carry A11, you multiply it with B11. Then you carry A12 and multiply it with B11. You finish this row and this column. Then now you come back to this row and this column. A21 times B11. A21, B11. Then you write your plus. Then A22 times B12. A22, B12. So this is how we multiply two matrices, A and B. Now, let's see example in numerical numbers. Let A be this matrix and B be this matrix. This matrix have two rows, while this have two rows again. This matrix have two columns and two rows. So we can multiply it when the matrix of A has two columns, and the matrix of B has two rows. Now, AB solution will be, first keep the matrix of A 2, 1, 4, 0, and keep the matrix of B together 1 and 2. Then AB will be equal to 2 times 1. We have 2 times 1. Then you write your plus. Then 1 times 2. 1 times 2. 1 times 2. Then you close the matrix. You finish this row and this column. Then you come back to this row and this column.
4 times 1.
4 times 1. You have 4 times 1. Then you write your plus. Then 0 times 2. 0 times 2. Then now your matrix AB will be 2 times 1, 2, plus 1 times 2, 2, 4 times 1, 4, plus 0 times 2, 0. Matrix of AB will be 2 plus 2, 4, and 4 plus 0, 4. So this is how we multiply two matrices, A and B, and obtain our answer. So now let's do a multiplication of 3 by 3 matrix. We should consider and give attention under solution of this 3 by 3 matrix. Let's find PQ. PQ. First, write the P matrix. 1, 1, 1. 2, 2, 2. 3, 3, 3. And then write the Q matrix. 1, 1, 1. 2, 2, 2. 3, 3, 3. So now, when multiplying this matrix, phi q, let me open the matrix. First, when you carry the first row of the first matrix, you multiply it with the whole elements inside the second matrix. That is 1 times 1. 1 times 1 plus 1 times 2. 1 times 2 plus 1 times 3. 1 times 3. Then you make a space, you shift, and still this row, you finish this row with this column, then again this row with this column by making a space. 1 times 1, this 1 times this 1, then this 1 times this 2, plus 1 times 2, then this 1 times this 3, plus 1 times 3. Then we make a shift again and multiply still this row with this column by making a space. 1 times 1, 1 times 1, plus 1 times 2, 1 times 2, plus 1 times 3, 1 times 3. Then let's close the matrix. You finish this row with whole of this matrix. Then you come to the second row of the first matrix and multiply it with the whole element of this matrix. 2 times 1. 2 times 1 plus 2 times 2. 2 times 2 plus 2 times 3. 2 times 3. Then you shift, make a space and multiply the row with the second column of the other matrix. 2 times 1, 2 times 1 plus 2 times 2, 2 times 2 plus 2 times 3, 2 times 3. You make a space again and still multiply the same row with the next column of the second matrix. 2 times 1, 2 times 1 plus 2 times 2, 2 times 2 plus 2 times 3, 2 times 3. Now you finish this row with the whole matrix. Then the last row with the whole matrix. We have 3 times 1, 3 times 1 plus 3 times 2, 3 times 2, plus 3 times 3, 3 times 3. You make a space and still multiply the same row with the second column of the second matrix. 3 times 1, 3 times 1, plus 3 times 2, 3 times 2, plus 3 times 3, 3 times 3. You make a space again and multiply the same column with the same row with the last column of the second matrix. 3 times 1, 3 times 1, plus 3 times 2, 3 times 2, plus 3 times 3, 3 times 3. So now, then you conclude your matrix. Matrix PQ will be equal to 1 times 1 is 1, plus 1 plus 1 times 2, 2, plus 1 times 3, 3. 2 times 1, 2, plus 2 times 2, 4 plus 2 times 3, 6. 3 times 1, 3, plus 3 times 3, 6, plus 3 times 3, 9. Then 1 times 1, 1, plus 1 times 2, 2, plus 1 times 3, 3. 2 times 1, 2, plus 2 times 2, 4 plus 2 times 3, 6. 3 times 1, 3, plus 3 times 2, 6, plus 3 times 3, 9. Then 1 times 1, 1, plus 1 times 2, 2, plus 1 times 3, 3. 2 times 1, 2, plus 2 times 2, 4, plus 2 times 3, 6. Then 3 times 1, 3, plus 3 times 2, 6, plus 3 times 3, 9. Then you close the matrix. Now matrix PQ will be equal to 1 plus 2 plus 3, 6. 2 plus 4, 6 plus 6, 12. 3 plus 6, 9 plus 9, 18. Then 1 plus 2, 3 plus 3, 6. 2 plus 4, 6 plus 6, 12. 3 plus 6 plus 9, 18. 1 plus 2 plus 3, 6. 3 plus 6 plus 9, 18. So this is how we multiply matrix of 3 by 3. Hope you all understand how we did this solution. So this is the end of this video session. Thank you for watching. Please don't forget to subscribe, like, and make a comment. And if there is any question, please leave your question in the comment section below. Thank you very much.